Hello, my name is Rebecca Shen. I'm a fourth year medical student at Duke University, and I'm excited to share with you today our project on developing an ED rerouting AI support tool. To give some background, ED overcrowding is a well known national problem that affects both quality and access of care. Overcrowding can lead to the need to go on diversion status, where incoming emergency medical services are sent to a different ED. These decisions are often made reactively and subjectively, leading to poor outcomes in many metrics. Our solution, therefore, was to build a pre hospital traffic control support tool that utilizes real time ED census data. This would help drive the decisions as to where patients are transported and hopefully ultimately reduce the need to go on diversion status. The first step of our process was identifying a way to define hours of heavy ED workload. To do so, we looked back at a retrospective 3 year period between our two Durham based EDs. We aggregated data of interest into hourly observations to give a snapshot of how the ED was changing on an hour by hour basis over the 3 year period. The data inputs we chose to focus on included the total count of the number of patients, the elapsed time of how long our patients had been in the ED since the hour of their arrival, the ESI score as an indicator of their case severity, as well as utilization of resources like psych and O2 requirements. This is an example of what our data inputs ultimately look like. We grouped the data into a table representation for each ED, where each row represented 1 hour of data for the ED. For algorithm development, we sought to label each of those hourly rows with its own workload label. To do so, we created 4 different categories of workload capacity. These included low, medium, high, and critical. And at least for the first iteration, these were simply defined based on the number of people in the ED during that hour as a percentage of the maximum capacity seen by that ED over the 3 year retrospective period. For our second version of our algorithm, we decided to add some nuance to that simple categorization in that we boosted the capacity based on input from our clinician collaborators. This is based on their experiences of what they had seen in the ED during their time working there, of what other indicators might indicate an incoming critical period. For example, we added boosts for greater number of severity level 1 ESI cases, as well as ventilator use. We validated our algorithm against the ground truth, which was the historical diversion data at our two EDs during the 3 year table. We labeled these diversion hours in our tables and looked at the proportion of critical, high, medium, and low workload labels in the hours of diversion, as well as the hours leading up to diversion. We continued to iterate on our algorithm, and in our fourth and final iteration, we found that this version was best at increasing the proportion of high and critical hours represented during diversion and in the hours leading up to diversion. In conclusion, we were able to summarize the hourly time course at our two EDs over the historical period using our workload labels. We hope to use these labels to design a capacity meter vision tool for EMS providers to have in hand and in the field in order to guide where they are transporting patients based on real-time ED census data. And there are many pros to our approach, as you can see here. And here are some next steps that I would like to see our project move into. Thank you so much for listening.